I'm Dan Toohey. I'm a chief technologist with Advanced Concepts Group at Mercury Computers. I've been there 23 plus years. It's been a minute since I've been in the ETT VSO forum, but historically, I was there with Greg Rocco and a number of people in this room when we started VPX, when we started OpenVPX. I still run the 46.11 system management group, and for the last, 6, 7 years, I've been doing system management over in SOSA. And that led to an update of 46.11 in 2022. So I'm going to talk to you a little bit about what we see for the future, a little bit about the past first, I think, let me see what I say. Okay, wait. So first off, we're going to talk a little bit about MOSA and VSO and how VSO sort of has been ahead of what the original MOSA directive is and has really, helped to make MOSA what it needed to be into the DoD. We're going to talk a little bit about the history of commercialized system management and how in the VSO and in standards that leverage 46.11, we have leveraged the learnings of the commercial industry and their roadmap all along to develop our own roadmap. We're going to talk a little bit about what we've standardized within the VITA forums and how that's been used, and how we think that we want to advance that roadmap as we move into 100.20. And then I have a couple slides that show some examples of how things are used today and how things might become even more manageable as we move into the future. So first off, if you hadn't seen it, in December 2024, the Tri-Services did reaffirm their MOSA directive. And I found two things interesting, right? One is that the reaffirmation came with the installation, before a new president comes in. So we want to make sure that money keeps coming for that. But secondarily, in the 2019 affirmation, they really only talked about the need to have to go out and leverage open standards. And really, there were 5 actual tiers to that, or 5 actual pieces to the original directive of MOSA in the DoD. So in this reaffirmation, they actually did go off and talk about more than just using consensus-based standards, but they talked about the principle of building modular design, right? Building designs based on the functions, the key of interfaces, right? You could build the great modular chunks, but if you can't put them together, it's not going to get you anywhere. You need to have environments like VITA, right, that allows you to actually build these standards, and you need to have a way to make sure that if somebody builds something, that the two things are actually going to come together, and that's really where conformance comes in. So when you go look at what VITA does, everything that happened in VPX before there really was MOSA was really driving sort of these functional partition of boards that wanted to come together in the logical architecture of planes. So we started out in the early days saying we want data planes, control planes, management planes, sensor planes, and we need to make these things interoperate. And then, what kind of cards would kind of put those together? Well, we started to build on their switch cards, there's payload cards, and payload cards have certain sets of functions. So, what I really like about the VITA community is that the VITA community seems to be at the forefront of what's going on. And when I see all the slides and all the work that's going into VITA 100, right, we're actually ahead of that community again. What VITA does define, right, is they build up those distributed systems. And these distributed systems can be quite complex when you start to get beyond a couple of cards. So in the MOSA environment, right, it's awesome that in an open VPX environment, I can now plug together cards from multiple people and not have them start fires in the labs. It's great that I can actually put together a power supply system and order a backplane from different vendors, and you can actually, again, electrically work, mechanically work, cooling work. But what the real MOSA initiative is I want to be able to update our systems as fast as I can in the field and really reduce the time in which I get those updates out and working. I mean, when I started at Mercury, I think our cycle times on new products were 20 years, right? It took about 20 years, right, for the government and some of our customers to actually update all their hardware, all their software in the field. And right now we're looking at things that are in, it went to like 10 years, then it went to like 5 years, and now, right now, right, it's not the fact that hardware and software doesn't come out and play together, it's the fact that it takes too long to put it together and integrate it and test it and verify it before you can field it, that you really can't get beyond sort of that 5-year cycle. What's the solution for that in the commercial world? It's system management, right? A good system management infrastructure allows you to standardize on all those common activities that you need to do, and allows you to build quicker schemes to integrate, quicker schemes to validate, quicker schemes to debug, quicker schemes to just do the whole shebang. And when we started to do 46.11, right, we got a lot of pushback saying that, no, we don't have a lot of commonality, but the reality is everybody wants to know what's inside the system. They want to be able to configure the system. They want to be able to isolate faults. They want to be able to report and collect that data. And then they want to optimize their system, because you don't want to be burning power that you're not actually getting application usage out of it. So when we started to look at management in the day, I like to call the genesis of all management and processing systems really comes from the networking world, where they developed this FCAPS model that went with the OSI architecture when they were building basically the architecture for networking. And what was interesting then is they had a modular approach to it. This is back in the 80s, right? And they envisioned that there were sort of 5 different kinds of management that I would want to do of a network. And there's fault management, configuration, accounting, performance, and security. And they actually envisioned at the time, right, that would sort of set up all these different standards that would come out and try to solve those problems. The reality was, in the implementation, that people built single solutions to solve all of those management domains. And as you go into more modern networking, you could actually see where the same capability can overlap, and it's reduced down to like 3 focus areas. Well, when we started building management inside VITA and in the standards that use it, we leveraged the same mentality. The only difference is we didn't use accounting, we used availability, because a lot of the same functionality you would do to charge people for usage of your line is also instrumental in understanding where can I use that for my application. Things like what's the speed of what's going over the link, what's the actual data throughput, what resources are actually running. The second sort of big deal what we did when we did this management was IPMI. So when you hear everybody talk at VITA, when you go and look at all the VITA specs, right, VITA's really historically about hardware infrastructure, right? The majority of the standards are how do I build hardware that interoperates with each other, allows me to put those hardware pieces together. The only real protocol standards, there's protocol standards, but I would say it's probably a small percentage of VITA overall. But IPMI was already, developed in the 1990s, was the sort of the bedrock of hardware management. We saw presentations already today that IPMI was adopted in some of the newer standards as well. I mean, it's kind of funny, right? We're adopting it still today, but it's a standard that's, for all intended purposes, has stopped, right? Basically, it's actually so good with the ability to put in all the extensibility within your own standard that Intel decided, let's not go back and update this standard anymore. It already sort of does what it needs to do, and it's been proven to do that. So there are lots of standards that build upon it and layer upon it for their manageability, and they still do that today, and then you can just OEM all your commands. And that's what we've done in SOSA. That's what happens actually in 46.11. So the fact that the standard is no longer being updated shouldn't stop you from using it. But what it does allow you to do, right, is it allows you to do the functions that we've listed here, which are basically about inventory configuration, diagnostics, and recovering your system in an out-of-band manner from where the application is running. In 46.11, it took us 8 years to build this standard, and it really was because, one, VITA really hadn't had the muscle of developing true protocol specs, messages talking across to things and people intercommunicating, and how you were going to actually verify that systems interoperated. But also, there was a lot of hesitancy in defining the kinds of things we wanted to do for People were nervous about the security of the IPMI infrastructure. People were nervous about, could you truly standardize on functions? And what we did do when we built this is we ended up building a tiered system, and we set those tiers with modular functionality. They grow upon each other. And we use that as a way to say, at the bare minimum, I want to be able to put things into a box, and I want to be able to tell what it is, read its temperature, read its voltages. And that was agreed upon to be common. And we had these sort of low-level things to say that temperature's good, voltage is good. But if you went up to the higher tiers, you could now actually go off and read all the individual sensors out of band. You could read detailed information on the FRU. You could do resets. You could do power cycles. You could do all those other features that allowed you to actually do low-level management in the box that traditionally prime integrators were building in custom ways with different products from other vendors. So now we get to 100. And really, what do we want to do with 100? We want to build again upon what we've been doing, and we want to start to answer the questions that, to the problems that people are now needing to customize on when they do 46.11. So, we get a lot of experience from people that are in SOSA, but we also get a lot of experience from the customers we work with on specific programs. And one of the biggest issues that we do have, right, is there's growing concerns for security. And there is a growing desire for doing configuration with larger data sets. So when we do configuration today over an IP and B bus, it's a pretty slow interface. It's an interface that we did add some security in 2022 about putting in firmware firewalls and bridging firewalls so that you could limit what kind of commands may go across the buses. But it doesn't have an inherent way to do really good encryption, really good authentication, really good integrity checking on the messaging. So what we'd like to do with 100 is we'd like to actually build a net-centric out-of-band manager so that we can leverage all of the networking security protocols and capabilities so that we can increase the security capabilities of that system, but also with a network interface versus an I2C shared bus, we can increase the bandwidth and the throughput of what we can transfer over that information. And what that will allow us to do is that's going to allow us to do larger things like updating your firmware in a secure manner over your interface. While 46.11 leveraged standards like IPMI and the FCAPS as a guiding principle and the ATCA standard and PICMIG as sort of the system level standard of the management, what we're looking to leverage here or learn from, right, is things like Redfish and the DMTF, all the work that they've done in commercial systems for sort of cloud computing and distributed processing systems there today. In SOSA, we've adopted RESTful interfaces as a way to communicate with that's a state of the industry way to talk to these interfaces versus talking through IPMI commands, and they have the inherent security principles that you want to have inside those systems. From a key functionality, the only one really that we're adding over what we had today discretely is we're looking to add in network management because we need to be able to control the network if we're net-centric in our out-of-band interface. And for those the people that were talking before, when Greg was talking and Steve was talking, we want to have backward compatibility with 46.11 and VITA 65 system management because we do anticipate people are going to have sort of mixed breed of VITA100 and VITA 65 systems, just like they did in the original days, right, with VITA 65 and VITA 46, or even in some cases VME systems. Three other things that we're going to look to do, and I think it aligns pretty well with what Steve had talked about and Greg had talked about, it is we want to focus our development and what we bring out based on user needs. We actually did that with the tiering system in 46.11 and how we added management into SOSA, is we want to focus on the problems that are most common and the problems that people want to see solved. And we want to work through those scenarios, right? We don't want to sort of prescribe, these are the commands you have so you can go do this. We actually want to walk through those use cases and make sure that we're actually covering the problem. Second, One of the things that's happening, at least in DoD acquisition, is there is an increased focus on assurance. And assurance today, a lot of assurance is really done through sort of DFARS and not through acquisition requirement language. And when the acquisition requirement language comes, there's going to be a lot of formality in how you actually provide artifacts for your requirements. You know, today, VITA focuses a lot of their standards with the idea of compliance. Compliance in sort of a system engineering approach is typically meant to be things like governmental regulation and meeting emissions laws and things like that. You know, we're going to try to use the word conformance as long as it gets accepted by the VSO. And what we want to do is we really want to look at the number of requirements and how those requirements are formed so that we actually can have the generation of artifacts that prove conformance at the lowest cost and in the quickest time frame. There are definitely standards in VITA where you might go through a program where you have standard referencing a standard referencing a standard. All of a sudden you have 3,000 requirements. That adds a lot of cost and time to a program. We need to start thinking about that as we're developing our standards so that we're actually putting real requirements in that are really requirements and what it costs us on the backside to prove that. And the last thing is, you know, MBSE. We've been using MBSE a lot to generate our standards in SOSA within system management, and it's because the complexity of thousands of messages and that traceability through the requirements and the verification or the conformance verification is difficult to track, right? And just even the generation of the tables, we save a lot of time by doing that through MBSE as a tool. The other thing about MBSE is we're moving into a world where MBSE models, right, are going to be our conformance proof, right? You're going to see things like digital twins, and the ability to show it in simulation is going to be eventually, right, better than showing it when you put the whole system together and test it, because you're going to be able to test corners and cases that you could never actually generate inside the actual integrated system. So lastly, I just wanted to show some really simplistic idea of how management has progressed today and how it can get better with VITA100. I picked a really simple one, I'll say, to draw. And this is really about power management. And one of the things that happened when people were upgrading VME systems to OpenVPX systems was the amount of power draw that you had in each one of your cards would cause your power supply system, it couldn't respond fast enough. And one of the ways people solved it is put a whole bunch of caps and do it, but not everybody could solve it by adding in all of the capacitors and things. So one of the things that you could do in 46.11, or you could do without 46.11, is you could say, I want to control the power into each individual slot. So that way I wouldn't get a surge of the entire system at one time, and then maybe I could use my old power supply as I'm migrating through my path. So in this case, right, someone would have to build a custom backplane, leverage their 46 modules, put a system manager somewhere within the box to control that, and then sequence up the powers. When we went to 46.11, you ended up with that individual electronic circuit breaker on every one of the cards. You could actually locate your system management remote to the system because you could come over Ethernet, talk to your chassis manager, and your chassis manager could say, turn on this card, turn on this card, turn on this card, turn on this card. He could control the sequencing. As we go into VITA100, we can do the same thing, but now we can secure those commands. We could multicast those commands. It gives us, you know, that greater security onto that path, maintaining that same capability by talking into that network interface on the device. So I can't show you all this great specs and things like Greg did because we haven't started our group yet, but what we are going to do is kick off that group at the face-to-face on Wednesday. We have 2 sponsors today. We're looking for more sponsors. So please join us through this fun. And, you know, summary, MOSA's growing. VSO has really helped MOSA grow. MOSA's enabling very complex systems. Complex systems need to be managed. They can be managed in a MOSA standard way. And we think VITA 100.20 is going to help keep pushing that forward. That's all I got. Any questions?